This video contains step-by-step instructions for verifying that the copy of Electrum that you download has been signed by the PGP key of the Electrum developer, Thomas Vogtslin. So, first we'll import the Electrum PGP public key from the electrum.org website. Then we'll download the Electrum installer plus the signature file that accompanies the installer. Then we'll verify the signature file using Cleopatra, the Gpg key management software that is part of the Gpg4win software bundle. Now we've already installed that software bundle. We're using version 3.0. We're using Windows 10 and Google Chrome. So first step, import the public key. We'll go to http://electrum.org. Hit enter. Now we go to the download page. Now we want to click on the link that's near the top of the page that says Sources and Executables are signed by Thomas V. We want to click on this link that says Thomas V. That brings up a page on the MIT PGP key server. Ignore this text down here. What we want is this link here that says 7F9470E6. That link at the very top should open this page that says Public Key Server and then these letters that end in 7F9470E6. This blob of garbage, and there's a lot of garbage here, that is the public key. We want to select all of that and import it into Cleopatra. We can do this by pressing Ctrl-A on your keyboard, right-clicking that text, selecting Copy. Now, we go into Cleopatra, and once it starts up, we'll want to click on a button called Clipboard, right here. Once we've clicked it, select Certificate Import. Now, press No on this message. It's a request to do something that we're not going to worry about. What's important is that we have Thomas Vogtslin's public key imported, and we can see it here. Double-click on his name, and you will see this window pop up. The important part of this window is this, Fingerprint. So this fingerprint is a set of numbers that is a unique identifier for the public key that Thomas uses. Thomas has a corresponding private key, which, using cryptography, he can use to sign files or text that other people can then verify using his public key. And Cleopatra and other GPG software use the fingerprint to verify that that signature is linked to Thomas's private and public keys. So this fingerprint is important. Now, next step is we want to download the installer and the signature file. So we'll go back to that download page. We will now download one of these software files. We'll save that. We'll also want to right-click on the signature link to the right of that file and click Save Link As. And that will save an ASC file. Now we want to make sure we download both of those files to the same folder. That's important. Now let's go and find the folder that contains the ASC file and the actual Electrum application. So, if you've installed Gpg4win, you should have this option in your right-click menu. More GPG-EX options. Click Verify. Now, Cleopatra, being sneaky, has created a window back here. And this is Cleopatra basically saying that it has looked at the signature file and compared it with the actual file that was signed, the installer for Electrum, and it has verified that it is a valid signature and that the signature was created on this date with certificate, then this blob of letters. Now this blob of letters is the exact same blob of letters that we saw here when we imported that key. In fact, if we click on that, we should get the same window. There. So what Cleopatra did is say the signature is linked to a public key with this fingerprint, and even though it says here the data could not be verified, what's important is that it identified that fingerprint. And if we compare that fingerprint with the fingerprint that we imported, they are the same. So that is how you verify the Electrum installer has been signed by Thomas Vogtland's PGP key. Okay, casual listeners, you can stop now. I'll go into some more technical details about how to be a bit more nitpicky about verifying that the software and public key itself is owned by the real Thomas Vogtland. Okay, so this public key that we downloaded from the key server could have been uploaded by an imposter, by someone claiming to be Thomas Vogtland. It is actually pretty trivial to create a PGP private public key pair. It is not trivial though to produce any fingerprint. To duplicate and forge a fingerprint with all these letters is actually very, very, very hard. So the best we can do is we can find someone we trust who owns a PGP private key that they made themselves and that they keep secret for themselves, and that person has signed Thomas Vogtland's public key. So if we go back to this MIT website, that big string of text I told you to ignore, these are signatures that other people have made using their own private keys to communicate to us that they have verified Thomas Vogtland's identity and have verified that he is the owner and person that controls the private key that corresponds to this public key. So if you can find someone you trust in this list of names, and you've actually verified and got word from them that they own that key with a particular fingerprint, then you can probably trust that this Thomas Vogtland and this public key are the real deal. I don't personally know anyone in here, but I do know that Peter Todd, a Bitcoin developer, uses a PGP key that has a fingerprint that is on his Twitter bio and also matches what is shown here. So what I'll do is I'll just show you here real quick. Peter Todd and show you his yeah, I probably want this one. There we go. So Peter Todd's Twitter has a PGP fingerprint in his bio. This is not the best way to do it, but if you trust his tweets and you trust that he owns this Twitter account, then you can trust that this PGP key is probably his. So it is 7FAB114267E4FA04. If we go back to that page showing the signatures verifying that Thomas Vogtland's public key is owned by the real Thomas Vogtland, we can see this entry here that says Peter Todd 67E4FA04, those same 8 letters. And if we actually import that key into Cleopatra, then we can see the full fingerprint. There it is. And we can go back to Peter Todd. What was it? That text here? Let me fire up a 7FAB and 114267E4. Yep, it's the same. So Peter Todd didn't include the entire fingerprint because it's a lot of letters, and really it's okay security, I guess, to use that number of letters. But if we were to say, find someone who knew Peter Todd and signed their keys, and we trusted that other someone, then we could trust that Peter Todd is who he says he is and owns this public key. And because Peter Todd has signed Thomas Vogtland's public key, we can trust that that public key is owned by Thomas Vogtland. So that's really the proper way that you should go about doing this. Now, that's a lot of work. You have to go find some PGP key signing parties where you can find someone who is part of the Web of Trust, which is kind of a weird term, but Web of Trust is a concept where people sign each other's PGP keys to create a network of identified individuals. Kind of weird, esoteric, not many people do it, but people in the Bitcoin space that write software have to do it, because in a system that is decentralized, it's difficult to trust any central authority. So if you go to the bitcoincore.org website that has copies of Bitcoin Core that you can download, you'll see this right here, a link to an ASC file that contains a text file they can use to prove that these bits of software for running Bitcoin Core have been signed by someone whose key is right here. In fact, we can probably download this file. We can import that using these commands. Go back to Cleopatra. No. Okay, so Vladimir J. von der Laan is, according to the bitcoincore.org website, the owner of the PGP key that signs the binaries published by Bitcoin Core. So that's a very important role. And you can go over here, find out the fingerprint. And so if you download a copy of Bitcoin Core and it has a fingerprint of a signature that is different, don't trust that copy. That is not a copy that you should use. And again, Vladimir J. von der Laan, you can go back and find his key on the MIT website, probably. Let's see, Vladimir, probably not in there. You can do that by going to this page, typing 0x, because reasons. Searching for that. There it is. That is the public key that you could download from the MIT website. And you can go to this user ID, which should give you, here we go. So these are people that have signed the key that Vladimir owns. So these people, if you can verify their identities, you can then trust that this PGP key on this website is the one you can trust for verifying Bitcoin Core copies. And there is another website that you can use. I'll show you real quick. PGP key statistics, I think. Oh, there it is. Yes. So PGP Pathfinder and key statistics. Click on that. So this is a website that kind of does that busy work for you. It's a shortcut. If you are truly paranoid and want to trust no one except for the PGP software that you use, then you should not use this website. But this website can be used to find signature links and paths between various people in the Web of Trust. So for example, I can go back and find Thomas's key, enter part of his fingerprint into that search, and then I can, let's say if I want to use Peter Todd as a link, I can enter in part of his fingerprint there and click Trust Paths. Actually, it should be the opposite. Find the reverse path, excuse me. Okay, so it's pretty direct, but Peter Todd has signed Thomas's key. We saw that already. The reverse path is also kind of true. Thomas has actually signed Matt Corallo's key, who has then signed Peter Todd's key in return. Thomas has also signed Luke Jr.'s key, who has in turn signed Peter Todd's key. So if you did trust Thomas Vogtland, you can also probably trust these people at the end of these chains. These are links, trust paths as it describes. It's a shortcut. Again, you can do this manually by going to download all of these signatures and looking for signatures in each file. Unfortunately, I think Cleopatra is not very good at showing the actual signatures contained within each public key. So, unfortunately for you, you'll have to use the command line version or use GPG tools for Mac OS or Gpg for Linux. But that's a quick way for people who are technically minded, who are also paranoid, that want to be able to figure out that what they download is actually from the person who they say they are. Also, one more thing, I wanted to add a quick note on the method of proving that certain keys have signed other keys. Cleopatra is actually really bad about that. It doesn't show the signatures of a given public key that you've imported, like the MIT website does. And if you do not trust the MIT website or any other key server to show you accurate trust information, you can use your own copy on your own computer, and using this command, gpg-list signatures, and then you can actually use part of the user ID, part of the public key, and assuming there's no duplicates, you should get a big list of things. So this big list that GPG returned in command prompt in Windows is basically what the MIT website showed, except it doesn't show the names of other people on the signatures because to save space it omits that information. MIT can afford it because they're a big server that has a lot of keys. For me, on my computer, my copy of GPG only has Peter Todd's signature in it. And again, there's that list of letters, 7AB114267E4FA04. So, if you're really paranoid, what you want to do is you want to use the MIT website, download each and every one of these keys of a person whose key you want to verify. You want to find out who these people in turn have signed their keys. So Peter Todd in turn he's had his key signed by this many people, which is a lot, and you want to import every single one of these keys, and in particular look for the SIG3 keys, or the signatures that say SIG3. There are certain levels of trust that you can communicate using your signatures. SIG3 is the highest. It basically means that you've done the equivalent of looking at someone's government ID, or you've known them for a very long time and you trust them. People that give out these SIG3s too much are probably not to be trusted, but people that do have good key signing policies, that are very strict about whose keys they sign, well, if they have a signature that's a SIG3 level, you can probably trust their signature. So, again, command line is what you want to do if you're really paranoid using GPG. If you're really paranoid, you want to compile it yourself, look at the source code. At some level, though, you probably want to establish a level of trust in some software, or even some group of PGP software developers. If you're okay with trusting MIT and whoever runs their key server, you don't have to do this. But if you really want to make sure that you don't trust anyone, well, this is about as close as you can get. Again, GPG, it's got a lot of other commands, you can make keys, do a bunch of other stuff. I won't go into all that. I just wanted to make sure you know, if you're really paranoid, use the command line, do it yourself.